right, so here we go. This time we're being told which formula we want to use. We want to use the half angle formula, or one of them, or all of them, to determine sine, cosine, and tangent for this angle here. And notice it says exact values, right? Exact. And basically what that means is, for example, when you have like square root of 3 over 2, and you put that in the calculator, I don't know this off the top of my head, I think it's 0.877, yeah, so, or 0.887, so this is approximately 0.866, It keeps going because it's irrational. So anything we write here, you know, even if we write all the digits that the calculator gives us, it's still going to be rounding it off, and it's still going to be an approximation. So this decimal approximation of the value is useful, but it's just that, it's approximate, right? It's useful in certain contexts, but we also really need to be able to get this exact expression, right? This is a way of showing exactly what value we are talking about, root 3 over 2. So this is just, I'm not saying this is the answer to this question, I'm saying this is an example. This is just an example of exact expression versus approximate decimal form. So we're after this one right here. Okay, enough about that. So we want to know exact values. So how do we do this? Well, it tells us we want to use the half angle formulas. So let's look up the half angle formulas. We wrote these out the other day. Notice, hang on one second. Notice on your toolkit, it says half angle formulas. And under that, you have something like this. And if you look in your textbook, this is referred to as actually a power reducing formula, right? This is called a power reducing formula, not a half angle formula. And later, they give you another form of this same identity and call it a half angle formula. So the way I gave you the toolkit, maybe I should have written it a little differently, but it's the same thing. You just have to solve it here and switch the variable a little bit. And I showed you guys this in class, but when you rewrite this thing, it's going to look like this. All right? So you can, if that's not written in on your toolkit, you can go ahead and write that in. Similarly, next to the cosine half angle formula, you can write this. And next to the tangent half angle formula, you can write this. Let me make sure I get this right. Okay. 1 minus cosine u over 1 plus cosine u. All right. Let's get all this. This is all going to be important. Let's just shrink it down a little bit. All right. So now, our goal is to work with 67 and a half degrees. Now, what you're going to notice is that if we take 67.5 and we multiply it by 2, we get, what do we get? We get 135. So this degrees times 2 equals this many degrees. Okay, so basically in these formulas right here, if we say that u is equal to 135 degrees, then what would u over 2 equal? Well, it would be half of this, which you can see is this. Okay, so all we have to do then is say this is our u over 2 in all 3 of these, this is our u in all 3 of these, right? Okay, now the good thing is, also you notice, in each case, it depends only on the cosine of u. Well, what is the cosine of 135 degrees. So you can go to your unit circle and you can look that up. 135, is it there? Yeah, it's there. This is 45. This is 135, okay? And it's also known as 3 pi over 4. And the cosine here, well, you can't tell really well from my sketch, but the cosine there is negative root 2 over 2. So that means that this, and this, and this, and this, they all just equal that, negative root 2 over 2. I can just throw that right in there. So here we go. Sine 67.5 equals minus negative root 2 over 2. And I'll simplify all these. Well, let's just simplify as we go. So this is 1/2, and this becomes plus a positive, and this 1, I can make that into 2 over 2. So, it's going to get messy there. 2 over 2, okay. So I can say that's 2 over 2 plus root 2 over 2, and just trying to simplify here. And then I can multiply those together. And when I take the square root of something, I square root the top and I square root the bottom as well. So I'm done. So there you go. So that is an exact expression for the sine of 67.5 degrees. Okay. So now let's do, board work's getting a little crowded here, but let's do cosine. Cosine of 67.5. It's going to be the same thing. You notice the formula is almost exactly the same, it's just the other operation. So that shouldn't be too hard now that we have this. So plus a negative, plus negative root 2 over 2 here. Okay, so for the same reason, I'm going to get 2 minus root 2 over 2. I'll get square root of 2 minus root 2 over 4, and so that's going to be over 2. Notice the difference between putting a square root symbol over the entire fraction and over just the numerator. It's different, you see? Be very clear when you're writing how you make your square root sign. Make sure that if you mean for it to be over the whole fraction, it is. If you mean for it to be over the numerator, that's what you've done. Okay. And I guess I'll do my tangent over here since there seems to be some space left. Tangent 67.5 degrees equals square root of, all right, 1 minus and 1 plus, right? Yeah, here we are. 1 minus negative root 2 over 2. 1 plus negative root 2 over 2. So because the 1's are going to be 2 over 2, and because this is plus a positive, let's see, I'm going to have 2 plus root 2 over 2 all over 2 minus root 2 over 2. Oh boy, this is getting crazy. All right, I'm going to need more space than this after all. Okay, let's keep it going just like Star Wars. Okay, so we have going to multiply by the reciprocal of that. Multiply by the reciprocal. Now I have a 2 in the numerator and in the denominator. Those divide to make 1. So I wind up with this. Okay, now, if you want to stop there, you're probably good. But I'm going to show you a way to simplify it a little bit more by rationalizing the denominator within the radical, which is kind of like some kind of a joke or something, isn't it? I'm going to multiply by the conjugate. See the conjugate? This is minus, the conjugate is plus. I'm going to multiply by that on top and bottom so that it's the same. Whoop. Didn't work out. Okay, so I'm multiplying by the same thing on top and bottom, so I'm not changing what it is because this is the same thing on top and bottom. And because it's plus here, whereas this is minus, and these are conjugates of each other, this is going to multiply to make something nice, as you'll see. So on the bottom, I'm going to do 2 times 2, root 2 times root 2, 2 times negative root 2, root 2 times 2. So this is going to be the difference of squares. You know what, I'll show it. I'll show it over here. I'm coming over here. 2 minus root 2, 2 plus root 2. Remember, all this is optional. So if you're still watching, you must be really weird. Haha, no, just kidding. Okay, 2 root 2 minus 2 root 2. And then root 2 times root 2, that's just 2. So I have minus 2. Seriously, if you can simplify like this, I will be overjoyed, and you will get more points. These two, of course, make 0. So this whole thing comes out to 2. So my denominator is 2. All right. Now on the top, I'm going to FOIL, just like I did over here, I'm going to FOIL again. I guess I'll do that up here. I mean, why not? This thing is already all over the place. So I get 4. I get 2 root 2. I get 2 root 2. And I get 2. Like terms come together. This is 6. This is 4 root 2. Okay, so on the top of this thing, I've got 6 plus 4 root 2. Finally, look at this. I can even reduce. I can reduce here, and I can reduce here because they both have factors of 2 in them. So I finally have the square root of 3 plus 2 root 2. Oh my goodness. I think I'm done. All right. Thanks for staying with me. And if I put one like this on the test, let's see if you can do all of this.